good evening, everybody. Today I'm going to talk about healthy soils for resilient ecosystems. Normally I would be talking to agriculturalists, so today I'm talking to nature lovers, students, conservationists, so please bear with me. I hope I've tried to target the talk towards a different audience. And I've learned a lot in the process. So a little bit about me to start. I was born and grew up in Naivasha, Kenya. I was schooled in Limuru, Kenya, and I went to school to do my A-levels in Zimbabwe at Arundel School. And then I did my MSc and BSc at UCT in Cape Town. And the reason I stayed at Cape Town so long was it was such a beautiful place, basically. And I really loved the university there. I love nature. I've spent a lot of time in nature. I grew up going to out on safari, camping in the game parks every holidays with my father, who's watching today. And I have done a few stints of working like on camel safaris and at the coast, and 6 months in Granba National Park, which was then in Zaire with Dr. Kes Hillman-Smith. Today I'm talking about this resilience of the soil. And here I have a photo of the house I was born in, about the year I was born. And here is a picture of my father's house today. So this is what resilience is. The ability to stand the process of time. So you can see nothing much has changed, except we've got a lot more trees. These are photos from Granba National Park. Here we have a little chimpanzee that was dropped off by some guests that bought it on the side of the road. We did a lot of work riding elephants through the park, and I did work on infrasound in elephants and different feeding patterns of elephants. And over here we've got Dr. Kes. We are putting a radio tracker on a northern white rhino, and you can see that it's a lot bigger than a southern white rhino, and we had to extend the neck collar, and she's taking a tooth imprint. So I was in Granba National Park in 1992. It was a gorgeous place to visit. It was a bit of a war zone then, and we literally spent most of the time in the park and lived on rice and beans, but lovely to live in nature. At the moment, I'm the TS manager at Crop Nuts in Kenya. I've got 25 years experience now in sub-Saharan African tropical agriculture. I'm absolutely passionate about the soils. And I like to go back to fundamentals. I rise to a good challenge. I love learning, sharing, and teaching. You're never too old to learn, and you're never too old to share what you learn with other people. It's great fun. And this is what I spend most of my time doing. This is me, and this is a soil pit. So I spend most of my time under the ground in soil pits, looking at structures under the soil and the roots, and seeing how we can maximize on soil health, soil properties, and maximize on the yield for the farmers. So it all starts and ends with the soil. And here's a nice picture of Africa. We'll start with a definition. Definitions change according to where you look, but the definition of soil is it's generally loose mineral, organic material around the planetary surface, and it holds liquids, gases, and biota, and supports plants. And you basically have good soil and bad soil. Poor soil has no resilience and doesn't yield much food and for animals or for humans, and good soil is absolutely full of organic matter and it supports a large biomass and large animal life. How long does it take to make soil? So it takes between 200 and 400 years, depending on where you are, to form 1 centimeter of soil. If you're in the mild climates in Europe and places, it would take about 200 years. In Africa, if you've got good rainfall and you've got a lot of plants around, we've got higher temperatures, we don't have the winters, and it takes less time actually to form the soil here in Africa. So all in all, it takes over 3,000 years to make good soil, which is quite a long time. What we want to know is, has the soil reached its tipping point? If it takes 3,000 years to build decent soil, and then we look and we see that over 25,000 tons of topsoil get washed away every year, washed into the sea and washed into lakes where they're no longer productive. And that figure is rising quite rapidly at the moment. And every year we lose, every year we lose 2,000 million hectares of productive soils by degradation, and 5 to 7 million hectares of soils are lost permanently, that have gone past the tipping point. Soil erosion, now we think about consciousness and thinking of other people. Soil erosion puts the livelihood of over 1,000 million people at risk. And that's people that are not directly responsible for the soil erosion. When we look at the population explosion that's happening at the moment, hopefully it'll slow down. But at the moment, we're sitting on about 8 million people. And by 2050, we're looking at 10 billion people. So by 2050, we have to figure out how to feed 10 billion people. To do that, we need to double our food production, the world's food production. Africa has 65% of the world's remaining uncultivated arable land. So if we're going to produce more food, and we have to look for more land, and one of the reasons we have to look for more land is we're losing so much productive land already. So not only do we have to look for uncultivated arable land to replace the millions of hectares of productive soil that we're losing every year, but also we have to look for additional hectares to produce this extra food that's required. So because Africa has so much of the world's remaining uncultivated arable land, the eyes of the world are on Africa for us to be the next global breadbasket. This will put incredible stress on our resources, basically, and especially on our game parks and natural reserves and the animals, because humans at the end of the day seem to always come first. One of the problems we have to face, in addition to growing more food, is that we've got climate change coming along, and it's increasing quite rapidly. So we're looking at hotter soils, we're looking at drier soils, we're looking at rainfalls that are more erratic, and when they come, they're much stronger, but and bringing much more damage with them. And we're looking at reversing soil degradation. We cannot possibly feed the world's population and all the animals without reversing soil degradation. And here we have a map of Africa from 7,000 years ago, and you can see that there's been amazing changes in Africa. Some of the main lakes are still here. Some of the lakes have dried up quite dramatically. If you look here, there's very little desert. You just have some desert down here. And semi-desert, but the whole of the top of Africa was grassland and suitable pastoral land. And we have a huge belt of forests and a large area of savannas. And now we look at Africa today, and this is a map from the FAO, and we're looking at the status of the soil degradation in Africa. And the red is not very nice. This is very high, severe soil degradation, and there's quite a lot of it. And then we have other areas with moderate severity of soil degradation, and only a few areas, and these are mainly in quite unapproachable places, of low severity. And then here you have the desert. This is desert. So it's called stable land or non-used wasteland. It's degraded too far, basically, for us to use. Again, we have the map here, but I've pulled up a map of all the national parks in Africa, just so that we get an idea of where the national parks are. And if you have a look, national park areas are in areas where we see very high to moderate severity of land degradation. So it's really important that not just agriculturalists and farmers, horticulturalists look at soil degradation, but also conservationists and people in charge of conservancies. When we look at the composition of the soil, about 45% is the mineral particles, and these come from the parent bedrock that the soil is made from. So when you've got bedrock or the rocks that break down over time and get weathered, they make little particles, and that would be the mineral fraction of the soil. And then you have a small fraction down here, which is the organic matter. In an ideal world, and everywhere, we would hope for 5% organic matter in the soil. And this is the most important fraction of the soil. And this is the fraction that we can change with our actions. So we can reduce the organic matter, or we can build it up depending on how we treat the soil. And then if your soil structure is really good, you've got 25% air and 25% water. That would be your ideal soil composition. When we look at the mineral fraction of the soil, there's very little we can change. But we've got the clay, which is made of very, very, very fine particles, and it's a very sticky soil when it gets wet. It holds water. It's not very good at transferring water. So if you've got heavy clay soils, you tend to get a lot of puddling, and you don't get a lot of storage of the water inside the soil. Then you've got silt soils, which are slightly bigger soil particles. Silt tends to be, it's got quite a high CEC, but it tends to be quite fragile. And then you've got sand, which much larger particles. It's much more porous. It allows really good water infiltration and air spacing, but it doesn't hold much water. So an ideal combination of all these different soil particles would be a loam. So if you're ever looking at farming, you're looking for a nice loamy soil, which mixes together the clay, the silt, and the sand into a nice mixture that's got the ideal properties. So it can hold on to the nutrients, it can allow water to infiltrate, it can allow air to move in and out the soil, and it has a good water holding and nutrient holding capacity. So these are your ideal soils, but not many of us are blessed with ideal loamy soil. When you look at the organic fraction, we have to understand that the soil is an ecosystem. In fact, the ecosystem below the soil is probably just as complex and as large as the ecosystem above the soil. And the ecosystem starts with the plants. So the sunshine shines on the plants. Plants are anchored in the soil and they take food and water out of the soil, and the sun shines on the leaves and they photosynthesize and they generate energy and carbon, organic matter. And the organic matter goes back into the soil as waste or as plant roots or metabolites. So a lot of plants will exude. So down through the roots, they will send out root exudes that feed the soil around them. And this is a big and important factor for healthy soils. And on the organic matter, we have the first, so your second trophic level are the small feeders. You've got bacteria, fungi, nematodes that feed on the roots. And then you've got the next trophic level, which you've got slightly bigger protozoa, which feed on the bacteria, nematodes, it'll feed on the fungus, arthropods and insects, and so it goes until you go up to bigger and bigger fauna. Sorry. So that's your soil ecosystem, and dung beetles in Africa are very important, and so are earthworms at burying the dung and the plant residues that are on the surface of the soil. To feed the living soil, so to feed all the soil organisms below the soil is like feeding 2 African elephants. This is a quote from Jerry Hatfield, the USDA ARS. So the sunshine shines on the plants, and then the plant residue and the exudes go below the soil to feed the microorganisms and the flora and fauna below the soil. If you take away the plants, then no energy goes below the soil, and the microorganisms and the whole soil ecosystem falls apart. When we look at soil carbon, 2/3 of terrestrial soil carbon have been lost from soils and vegetation on the soil since the beginning of the 19th century. This is a huge amount of carbon. It's enormous, and it's due to soil degradation. So it's the loss of the carbon in the soil and the loss of the soil's ability to grow the plants to regenerate the carbon. Soil carbon loss is one of the principal signs of soil degeneration. So when we're looking and we're doing our soil surveys, we look very closely at the levels of the carbon in the soil. We measure them. We measure all sorts of different types of carbon. So we're looking at the total carbon in the soil. We're looking at the inorganic carbon, which comes from things like lime, calcium carbonates. We look at, that's supposed to be, and the organic carbon is the most important. And organic carbon is then again split into active carbon and passive carbon. So the most important carbon for us, for our soils, we're looking at is organic carbon and active carbon. If we were to increase the carbon in our soils by just 1% in the top 1 meter of soils around the world, we would reverse the climate change. That's how powerful soil carbon is. And if you look at the different amounts of carbon that is stored in the, you've got carbon in the atmosphere, you've got carbon in the biomass, the vegetation above ground, which is 450 to 680 gigatons. And then we look at the soil carbon. And by far the most carbon in the world is in the soil. And then we look closely at the soil and we're looking at the top 30 centimeters of the soil is the largest fraction of carbon in the soil. So soil carbon is most important. And when we look at, for example, the Masai Mara and the rangelands, the Laikipia region, rangelands contain 1/3 of our terrestrial carbon, and they have the highest potential of all our land to sequester more carbon. So when we're looking at trying to reverse climate change, sequester carbon, we need to focus as much as possible on the rangelands without losing sight of anything else. Reversing land degradation, soil degradation, and increasing soil carbon is the surest and lowest cost multiple win situation for saving our planet. And the rangelands is one of the best ways to do it. If we look closely in the soil, and this is another thing I look at a lot, is the soil structure. So the soil structure is determined by the mineral fraction of the soil and how much clay, silt, clay, sand are in the soil, but most importantly, whether it's aggregated or not. So soil aggregation is really important, and this is a soil aggregate. It's basically a big crumb of soil that's held together by roots. So you can see the roots sticking out, by roots, organic matter, and you can see a whole lot of insect holes, so insect activity. And inside that crumb, you'll have what we call micropores, microaggregates, macropores. You will have a lot of microorganism activity, so funguses and bacteria. And what happens when the soil gathers together in these aggregates or crumbs is it becomes very resilient, and it can resist soil erosion. It can resist being broken apart by rainwater. It also aids the soil erosion. So if you've got a soil that's got no structure at all and the water falls on top of the soil, what happens is you get a lot of puddling on the surface and absolutely no water going into the soil. And when the water puddles on the surface, it basically creates a big slurry that just washes away, and you wash away your water and your topsoil. If you have nice big aggregates, what happens is you have a lot of pore spaces, so the water comes down, hits the soil and travels through the soil. So the soil aggregate formation is most important, and that is based on roots. So you need to have plants in the soil and the organic matter in the soil, and also the whole ecosystem within that soil. When you look at the soil horizons, what does the soil look like below the ground? The top layer is the organic, the humic layer, and it's not very thick. In some soils, it's not even in existence, actually. But you're looking at sort of 0 to 1 to 2 inches of soil maximum. And that's one of the most important layers of the soil. So it contains the organic matter. It contains all the seeds that you need to regenerate the soil. The organic matter that coats the top of the soil will reduce the evaporation. It forms a mulching effect from the soil, and it reduces the evaporation of water out of that soil. So it helps stop salinity formation in the soil. And then the organic matter up in this top layer will then break down and filter through. So with the action of animals, with all sorts of insects, with earthworms, that organic matter should crumble down and filter through topsoil. And then you've got the topsoil, which hopefully would be at least 30 centimeters. And this is the part of the soil that contains most of the minerals, all the plant nutrition, the organic matter. So this is really important for holding the water and for holding the nutrients and the nutrients and the organic matter that's required to feed the plants. When you're looking at the soil as well, you can see that you've got different rooting depths and the roots can go down to different layers. So the roots are a really important part of the soil and they help build resilience. So if you've got a lot of wind or water erosion, and your first line of defense would be obviously the biomass on the top, your second line of defense would be the roots and the soil aggregate formation. So the more plants you've got on the soil and the more roots you've got in the soil, the better for the resilience and also for the better for bulking up of the organic matter. What tends to happen when you have a regime change, so for example, if you cut down all the trees in the forest or you plow up the soil in the rangeland to grow crops, is that you get erosion or you get a breakdown of the soil structure and you lose the organic layer and the topsoil layer. So what you lose is the most important layer, is all the plant nutrients required to rebuild the soil and also the seed material that's required to rebuild plants. And then a really, really important part of the soil is mycorrhizal fungi, and a lot of people are talking about it these days. When I worked at Dudutech in Kenya, we grew biological fertilizers, and mycorrhizal fungi were one of the things that we grew. So mycorrhizal fungi, they grow with the plant roots here. So this is a root which doesn't have mycorrhizal fungi, and this is a root that's been populated by mycorrhizal fungi. And you can see that the area and the volume of the root is much, much bigger. So now you've got a huge area of soil that the plant can access to take up water and nutrients. And mycorrhizal fungi are very important, especially for trees and rangelands, and they grow with, some of them are very species specific. They bring a lot of carbon into the soil. So they build up the organic matter of the soil, they bring carbon into the soil, they help hold the soil together, and they feed the plants and increase the above ground biomass. And here, this is the entrance into our house. So we live down there somewhere, but I've planted 2 candelabras, both the same size plants taken from cuttings, both at the same size. And one plant here was planted with AMF, mycorrhizal fungi, in the root zone, and this plant wasn't. These were planted about 6 years ago and they're completely rain fed, and I don't put fertilizer on them. But you can see the huge difference in the growth of the candelabra with the mycorrhizal fungi. When you are doing, like, when you're repopulating or reforesting areas, it's really important when you grow the plant pots is to try and inoculate the roots of the trees with mycorrhizal fungi. And the best way to do it is to take soil from under a healthy tree of the same species and just mix it in with a potting mix. And hopefully then that fungi will grow with those roots, so that when you transplant the fungi out, when you transplant the trees out into the nature, that they will grow and repopulate the soil with this beneficial mycorrhizal fungi. And then you do get a lot of drought tolerance and increased biomass production. So the soil provides us with what we call soil ecosystem services, and the amount of, and the efficiency of their delivery of the ecosystem service depends on the soil health, the soil biology, the organic matter content of the soil, the structure in the soil, and the diversity of the organisms in the soil. Soil ecosystem services are really important. First, they support and feed plants. So they grow our food, and they also grow the food for the animals. Soil is really important to store water. It cleans water. So without soil, we wouldn't have clean water. Dirty water will hit the soil and hopefully percolate through the soil. And as it moves through the soil, it will be cleaned up by the soil ecosystem. Soil also acts as a carbon sink, which we know is really important now to reverse climate change, and it acts as a nitrogen sink. So nitrogen is also part of the problem with global warming. Carbon is obviously the worst one, but nitrogen is another one. So the more carbon and nitrogen we can actually sink into our soil, it's beneficial for our plants, but it also helps clean the air. That's really important. And then soils are important for nutrient recycling and storage. Without organic matter in the soil and without healthy soils, the nutrients in the soil for most, like the nitrogen, would be completely lost and there'd be nothing to support plants. And the nitrogen would end up in our waterways, and the phosphorus would end up in our waterways and cause eutrophication and dirty our water. So nutrient recycling and storage and making it available to the plant roots is really important for bringing clean water, but also for supporting biomass production. And then the soil detoxifies pollutants. So a lot of the, you probably don't want to know, but maybe the chemicals that we spray on our crops, the pesticides, the herbicides, maybe the tick dips are pollutants. They're basically unnatural chemicals, and they have half-lives, but they can hang around for a long time. If it wasn't for the soil being able to aerobically or anaerobically detoxify them, they would build up to large amounts within our community and our systems. Soils are also really important to recycle waste. So if you go to houses or hotels, lodges, you have sewage to treat, and of course it goes into the soil. Without the soil, the sewage wouldn't break down, basically. Soil is really important as well in suppressing diseases. So in the soil, we've got a lot of natural bacteria and funguses that compete with pathogens, or they can even eat pathogens. They prevent pathogens building up. So without good, healthy soils, you find that you get a lot of problems with the human population, with animal populations, with diseases, and with plant populations. So you get a lot of extra diseases without healthy soil systems. And then soil offers structural support. So that's the support for our roads, for our houses, for our factories. And soil offers habitat provision. Without soil health, we wouldn't have healthy plants. And without healthy plants, we wouldn't have healthy animals. And without healthy plants and animals, we wouldn't have healthy people. And without healthy soil, plants, animals, and humans, we wouldn't have good environmental health. And basically, at the end of the day, we wouldn't have the planet health. So the soil, this is called the One Health concept. Soils are important for determining all our health, from plants, animals, humans, environment, all the way to the planet. So I'm just going through a few case studies, and I don't know if anybody's aware in South Africa, but maybe the Kenyans are, is that our two major mountain systems are on fire. Mount Kenya started burning on the 13th of March, and these are pictures from Celia Behrens. And you can see how big the flames are. She's miles away, and these are the flames on the side of Mount Kenya. And if you look, this was posted 2 days ago from the Mount Kenya Trust. They're still battling with fires on Mount Kenya, and they're also battling with fires in the Aberdares. So these fires are happening. We've had global warming, we've had very dry weather, and very dry, windy weather, and we're starting to see fires all over the place at the moment. We're hoping for rain, it's coming. This is a picture of the Aberdares. And in the background, you can see the bamboo. That's your natural bamboo forest. And in the foreground, you can see shorter plants. They don't look like bamboo. And this shows you the resilience of the soil. So the bamboo would be the natural habitat that was there before. And this is an area where a fire went through, and the fire went through quite a long time ago. So we're talking about 5 or 6 years, a big fire went through. And this biomass is growing back. It's probably about as high as my waist, and in some areas a bit higher. But without soil resilience and without organic matter and nutrients stored in the soil, when you take the top cover off the soil, it would be completely washed away, and you wouldn't have this regrowth. Sadly, the regrowth is not the bamboo, but hopefully the bamboo would will follow. The fires have been sorted out by KWS and the Mount Kidney Trust and the Rhino Arc. So if anybody wants to donate money to help put these fires out, have a look on Facebook, please. Now, this is more from the conservationist point of view, but also from a farming point of view, is that biodiversity drives resilience. And here you have so you have a farming system that has still a lot of trees, it's got a lot of small fields, it's got hedges, the river's intact. And the crop, if you look, there's a lot of different crop diversity. So a farming system like this would have a huge biodiversity, and you can see how many animals would be in that farm. Once we start to maybe make everything a bit more efficient, we take out a few hedges, have larger farming areas, take a few trees out to make more space for our food, then we start losing species. And you can see as we grow in size and as we go away from diversification on the soil and the crop types, we start losing all our animals. So a system that has a large biodiversity is also very resilient. If you have changes in, for example, the climate, or you have extra rainfall, or you get a bit of flooding, the more species you have in that habitat, the more resilient the system would be. And when we look at the 5 drivers of soil biodiversity loss, because soil biodiversity is most important for resilience, is land use change, so cutting down trees, tearing out rangelands to put broadacre crops in. So that's a big problem. Invasive species, and this is probably quite a big problem in some of the game parks and things, is that when people come in from different areas, they can possibly bring different species in, or they can bring seeds in. And also when you're bringing building materials into parks, you can bring soil that's full of different species. So invasive species can be a big problem. And one reason it can be a big problem is you're taking a species from one area into another area, and there's no natural predators in the new area, so the invasive species can grow out of control. And what we're seeing a lot at the moment, like for example in Kenya, is an invasive weed it's a parasite actually called dodder, and it's moving through a lot of the road systems, and it's quite close to the Mara, and it's going into some of our forests, and it basically grows off trees and starts strangling the trees. And then unsustainable soil management practices. So when you're building houses or roads, one has to look at sustainability in the soil and make sure that the water runoff and the infiltration is looked at properly. If we look at some of the big disasters around the world, one of my favorite ones to show is the Texas Dust Bowl. So here you have prairie grass. When we look below the soil in prairie grass, we can see that these are really, really deep soils, and the root system of the prairie grass is huge. So under the natural prairie soils, you had incredible water infiltration of your soil, and also underneath there, huge amounts of organic matter. And now we compare it to row cropping, and I think this is wheat or barley, but you can see the complete difference. Now you're starting to get compacted layers here, dark layers. You can see that the rooting system is much smaller, and that there's less biomass on top to capture the water. So you get less water infiltration and probably less water storage, and also less access to the water because the roots are up here. So what happened with the Texas Dust Bowl is that farming got mechanized for a start. So the mold-balled plow was invented. And you could rip through the soil and break it all up, and this organic matter would decompose and feed the crops, which was a brilliant thing because inorganic fertilizers hadn't been invented then. So the prairie soils and other savannas like this were very fertile, and you could plow them up. But after a while, the fertility started going away. So the organic matter decomposed, released all the nutrients to the crop, and the organic matter wasn't there anymore to help with the soil structure and the water infiltration. and it wasn't replaced. And then what happened is that a lot of people came back from the war. So the Second World War, all these guys came back from the war and they needed to be employed. So a lot of people were given land in the Texas Dust Bowl area so that they could farm and support themselves. Suddenly there were a lot more farmers. And because there were a lot more farmers farming, the price of the wheat went down. So what the farmers did to compensate so that they could earn the same amount of income is grow more wheat. So suddenly huge areas of land were ploughed up to grow food crops and row crops, enormous areas. And what it did is it changed the local climate. So all the trees and the hedges were taken away, and these beautiful thick soils with natural grasses that were holding the soil together and storing water were taken away. And suddenly the area dried up and there was nothing to hold the soil. So the Texas Dust Bowl was a disaster, and millions and millions and millions of tons of soil were blown away, and an area where it was bigger than Texas was totally damaged. The soil was degraded, some of it to such an extent that it could never recover, and some of it very slow recovery. I think you're talking from the 30s to like 1959, so 30-year recovery stage to get the soils to start yielding again. And even now in this area where when you get dry weather, you get a lot of dust blowing around. So this is all the topsoil blowing away. It was actually Roosevelt that came in and he started the National Land Army, I think it was. And to rehabilitate the soil, they started crop rotations, smaller cropping areas. They brought in hedgerows and tree planting to try and bring the soil structure back, but it'll take many, many years for Texas to recover. And now we look at, this is a change of use of land. So character, Ivasha and Colleen and Holly, they're all about character. It's just above us. And these are Google Earth photos. So in 2001, this is our main road, and I live just along there, and this was character. It's an informal settlement. In 2001, you're looking at a few concrete roofs and actually a bit of farming going on. And now we look at the same area in 2021, we can see that the whole of character, this informal settlement, has been filled with housing. I mean, how the population grows, there is a demand for housing, we can't stop this. But what it does, this urbanization, is it basically seals the soil. So instead of allowing water to infiltrate, the water runs off. And this is taken from my car, just driving through the town. This is our local shopping area. And every time it rains in character, the whole place floods and the road floods. And this is because of this urbanization and the sealing of the soil, so you're not getting any infiltration, and the runoff from the roofs. And you can also see there's areas where we've got greenhouses. The greenhouses are actually catching their rainwater in reservoirs, but in these informal settlements, we struggle. There's not enough drainage, and there's no town planning. So what happens is everyone just gets flooded every time it rains. And now we look at the Mai Mahihu Road. This is Mai Mahihu Narok Road. So if anybody goes to the Masai Mara, this is the road you drive from Nairobi down to Mai Mahihu, off to Narok. And every time we get high rainfall, we get what they call cracking in the roads. So the roads get completely washed away. We get huge cracks in the road, as you can see here. And there's a big problem. And it's also incredibly expensive for the government to sort out every time it rains. In 2018, in a week, they fixed the roads 3 times. Basically, the road goes along here. We've got a mountain up here, this is Mount Longonot, and quite steep slopes coming down. And here's the road. And this is a very fragile, arid, dry, arid zone with not a lot of plant cover and a very silty, hummusy, sandy soil that doesn't hold water. So a very fragile soil. So every time it rains, this is what people see on the side of the road, and the infrastructure gets broken and needs to be fixed. It is thought to be a combination of erosion. Erosion is very rarely mentioned, or the movement of tectonic plates. But if you follow these channels from the road up to where they start, and you can also have a look on Google Maps, Google Earth, is you can see the land use here. We can see a lot of compaction. We can see a lot of roads going all over the land, breaking up the soil, a lot of animal paths. We can see a whole lot of miniatas. So there's a great deal of informal grazing going on here. And if you go further up, there's ploughing. So the whole soil in this area is being degraded to vast extent. So every time it rains, instead of the water going through the soil, it's taking the soil with it and running down the hills. A big problem we've got at the moment, some people think it's a curse, some people don't, is that the Rift Valley lakes are rising. So if we look at Lake Naivasha where we live, and we look at Lake Bringo, we've had a big increase in the lake level, which is a problem because, for example, in Lake Naivasha, we've got people that built hotels and informal settlements on the riparian land. So when the lake comes up, they get flooded and they lose their income. This lake is Lake Bringo, taken from Google Maps, and Bringo, the lake level has risen over 7 meters and it's still rising in the last few years. So we've got a picture from Google Maps of 2001, and you can see this is the lake, and you can see there's a peninsula here. And in 2021, I think this is only 6 meters rising. The peninsula's turned into an island. This peninsula was actually a wildlife area with a whole lot of giraffe and warthogs that had to be taken off by boat recently. So the peninsula's turned into the island, and at the bottom here we can see the wetland. This is where the major river comes in. There's a big swamp wetland that would previously be cleaning the water. The wetland's actually been flooded. So you can see that you've got a huge area here where the lake's expanded, and this has created big problems because it's flooded out a lot of people, taken a lot of hotels with it, and for example, population living on this island are very restricted in the amount of land they have left. If we were to look at the watershed, so for example, here's the Bringo watershed. It's a very dry, arid area. It's a large watershed, so 6,820 kilometers squared is the watershed. If we were to look at the watershed and calculate, for example, maybe it lost 20 centimeters soil, and that soil could hold 25% water in it, and it's been draining into this lake, which is 130 kilometers squared, we would wonder how much would that make the water rise. So if you do what we call a fag packet calculation, the loss of topsoil in the watershed area, if it was 20 centimeters, would create the lake to rise by 2.6 meters by the extra water, and 14 meters by deposit of sediment in the lake. So when we look at the Rift Valley lakes and wonder why they're rising, a lot of it has to do with the soil and habitat degradation in the watershed, and the fact that the soil can no longer hold the water, and also because the soil's been washed away into the lakes, and so it's causing the bottom of the lakes to rise up due to sedimentation. And another reason is actually that we've had increased rainfall in the past years, which is also causing the waters to rise. And here we've got pictures of Bringo and the watershed. So this is a house. This was actually a house on the top of a hill that's completely flooded. This is common in Bringo, and you cannot see it from the air so much, is we've got overgrazing on these very steep slopes and on the hills, and it's taken out all the cover, all the vegetative masses. In Bringo, you see this is a normal storm, and I don't know if anybody outside Kenya knows about it, but you have very short, sharp showers that carry huge amounts of water, and they can be really destructive. And this is what you see in Bringo here. So we're looking at even the aloes are drying up, a few thorn trees holding the soil together, but you're looking at huge areas where you've lost meters of topsoil. One of the reasons is that there's no land tenure in the Bringo County Council, although this is changing, and you have a lot of overstocking a lot of charcoal burning from the large trees. So you're losing quite a lot of the biomass and the organic matter in the soil. If we go to another area in Baringo, Teddy Bear Island, so this is this little island here. Teddy Bear Island is a small island shaped like a teddy bear. In March 2011, this would be a Google Earth picture of it, and you can see that there's a population, we can see animal compounds around, we can see paths and a few trees. If we look in at the Google Earth picture from 2019, we can see a huge increase in the number of trees in the area. And here we have some pictures from the ground. So this is a photo from May 2014 and a picture from September 2021, thanks to Elson Carstead. And this is a picture of Baringo grass. So what happens here is a small, it's been turned into conservancy, and livestock has been excluded, and the population that live on the island survive on conservancy fees now, so they don't have to have too many, they don't have goats and cows on the island. So they get income from conservancy fees, and they also do a little bit of agroforestry. So they've got an orchard, some orchards, lemon and orange orchards growing other trees, and some fish farming projects, and no longer relying on overstocking of livestock. So you can see that huge increase in that 7 years in the vegetation on Teddy Bear Island. And another thing is this Baringo grass has grown back, and a huge amount of the income for the islanders is now from collecting the seed and selling the seed to projects that are trying to rehabilitate degraded areas elsewhere. So they're getting a large income from this seed. So that's a really good project. How do we rebuild soils? So basically, first, when the soil gets washed away, it's lost a lot of its nutrients and its minerals, and it may become very acidic, or it may become very salinified or alkaline. So first we want to test the soil and balance the chemistry and the nutritional load back into the soil so that we can support, the soil can support plants again. Then we have to look at the structure. If it's compacted, maybe break through the compaction areas and protect the soil from being washed away again. Grazing management is really important. Soil develops so much faster with herbivores. And so here we have a buffalo herbivore. So the bacteria in the gut help populate the soil is one reason. And also when they feed on the plants, they chew up the plant matter and they break it down so that it's much easier to go back into the soil for the dung beetles and the microbes to feed on. And also so herbivores spit, for example, and other bodily fluids can also help repopulate the microsystems in the soil. When you're looking at herbivore and grazing management, and you can look at the migrations in the Mara with the wildebeest, is that mob grazing is a very effective way for rehabilitating soils and ecosystems. If you have enough biomass and the animals can go through it really quickly and graze it down very fast and then move on to the next area, then the soil will regenerate very fast and you optimize on your biomass production and your organic matter production. But grazing has to be managed. So in the case of Baringo, for example, where you've got overgrazing and the animals can go anywhere, you're getting no regeneration of the plant matter at all, and finally everything just gets washed away. And then reforestation is really important in the areas that have been where the forests have been removed, and agroforestry is also very important. So agroforestry is up and coming, and it's an old tradition, but a lot more focus has come onto agroforestry to develop it into our new farming systems. You can see agroforestry, for example, in coffee and tea, where they have the trees growing within it, but where agroforestry is being moved into a lot more cropping systems, which is brilliant. And it's important at all times to keep the soil covered and to keep living roots in the soils. This is to feed the microbes under the soil. If you take away the plants and you take away the roots, not only does the soil have no strength, but the living organisms underneath the soil have nothing to feed on. And then limit physical soil disturbance as much as possible. So every time we plow up the soil or drive over the soil and we're compacting it or moving it, we're breaking up the soil aggregates, we're bringing oxygen into the soil, which basically burns the organic matter away. So to limit this as much as possible, and then to diversify the plants as much as possible, so that you've got plants with long roots, short roots, plants that feed on this nutrient, plants that feed on that nutrient. The more diversification of plants, the stronger the system and the more biomass can be produced. And then water management, to make sure that A, the water goes into the soil as much as possible, the rainwater, and B, that as little soil as possible gets washed away. These are really, I don't know what the time is. These are really simple farming systems in Kenya. So the, and in Zimbabwe here is just to rough up the soil as much as possible, to put mulches on, just to improve the water infiltration and to hold the organic matter into these areas as much as possible. So roughing up the soil like this and leaving it like this will help regenerate the soil in a very quickly, and also will help bring up more profitable crops for the small scale farmers. When we look at soils and how to rebuild them, if you ever have time, you can Google it. But the lowest plateau in China, this was a large area of agricultural land which had a huge population, and as the population grew, so did the pressure on the land. So there was a huge amount of deforestation to provide wood for fuel and for housing, and an intense cropping. So what happened in this fragile system is all the soil got washed away and blown away. Most of the soil ended up in the Yellow River, which made it yellow. And the soil became totally non-productive, totally degraded, and useless for everybody. So in about 1979, a big project which was sponsored by the UNDP, let me just check, sorry, was made for the soil, and the FAO was made to improve the soil. So what they did is rebuilt the structure of the soil. If you can have a look, there we go, sorry. So if you have a look, we can see that the soil's been bench terrace, so to hold it together, roads have been put in, and the area was reforested, and permanent crops, so perennial crops were put in to the system to replace the annual crops that were there before. So if you look at this same area, but this huge change in the dramatic change in the environment, just by making sure that the trees were put back and the soil was protected from being washed away. So it was one of the world's most eroded areas, and once it's been rebuilt, it's 70% more productive than it was prior to when it was completely degraded. And this, I don't know if this will interest anyone, but we use this quite a lot in farming. I do like my looking at satellite pictures. On the bottom left, we've got a Google Earth picture of the Massa. This is in the Massa Mara. You can see a road coming through and a river going here. And on this side, you have a little town, and on this side is actually the game park. So you've got quite a lot of human action here. And now we can look at the NDVI. So we do a lot of NDVI work, which is basically looking at the biomass density using satellite. And sorry, my screen is in the way. So here we've got this same area with an NDVI picture taken on the 11th of January this year, when it was quite dry, and actually the Mara's had a few bits of rain, so we've got now the vegetation's coming back. And this NDVI satellite picture is taken on the 22nd of March. And we can see the huge regrowth in the, what do you call it, in the vegetation on the park side. And here, the red and brown areas, this is at like bare soil, basically, bare soil or bare rock. This is in the populated area. The dark blue is very high vegetative density, so that's basically trees or shrubs. And you can actually use NDVI as a method of monitoring fitness of ecosystems and biomass development and changes in the ecosystem. And you can also see where, for example, you've got animal paths going through and the soil's compacted. So NDVI is a really good agricultural tool that can be moved across to conservationists if you don't know about it already. So where to next? Basically, we need to build back the soil carbon. That's the main thing. So that's caused the degradation of the soil, and it's been caused by our actions. So the only way to restore the soil is to build back the soil carbon. So restore the soil and protect it, and educate and share knowledge. So this is why Share Screen Africa is so good. And where we come in is Crop Nuts, we are the home of soil testing. We analyze, monitor soil, air, water. We do carbon monitoring. So it's important to analyze and monitor the situation that you have so that you know when you're going away from a stable ecosystem, but also so that you can identify problems well before they start so that you've got time to fix them. And it's really important to protect our water and to store it. Make sure that it doesn't go all the way out to the sea, but actually filters into the ground, or we store it in reservoirs so that we can use it for our farming and for our conservancies to create biomass. And then big time smarter farming methods. So there's a lot more farming methods going out there: precision agriculture, minimum tills, no-till, climate smart agriculture, regenerative farming. These are all for yield intensification and carbon capture so that we can create we can grow more food on the same amount of land and also improve the soil quality. And then for us, we have to diversify as much as possible and reforest as much as possible. And then another exciting development is biotechnology, where scientists are developing higher yielding, drought tolerant varieties of major food types, and then also developing biofertilizers and soil inoculants that can fix nitrogen from the air and carbon from the air. So there's a lot going on the agricultural side that I hope will be very beneficial to the conservation side. It all starts with the soil and it ends with the soil. Thank you very much for your time, everybody.
Good evening, everybody. Ruth, you kept Holly awake, so that's something.
That's quite amazing, isn't it? Well done, Holly. Thank you, everyone, for clapping and for listening. I think there's a lot of there's skills that we can all teach each other for sure.
So the next question is, what does Marty's picture look like tonight? Because he's always got a picture on about the bird or the animal that we are discussing. So Marty, I hope there's a picture of soil on there. Right, so it's time for your questions. You're welcome to use the tools that Zoom provided us with, the reaction tools at the bottom, to draw your attention, to draw our attention to you, or you can just wave your hand and we will try to find you. I believe there are already a number of questions in the chat, so if nobody's waving at me at the moment, we can, Tom, I believe you've raised your hand, so you are welcome to unmute and go ahead.
Thank you. Fascinating, yet another fascinating program. Hats off to this group. Took several notes as you were talking, Ruth. I was hoping maybe you could say just a little bit more about your opening statement, which was a great attention getter. That 1% increase in the top 1 meter around the world would reverse climate change. Now, does that statement assume that we're removing it from the atmosphere and putting it in the ground, or is there another process involved in that? And then how long does it take for that to occur if we started doing whatever it is we need to do today? Second question is, where do I get me some of those microzoal fungi?
Ah, Tom. Thank
Thank
you.
you.
You're asking very difficult questions. The mycorrhizal fungi, you can actually buy them. So you get them in America. Where are you based? Where?
The Pacific Northwest, Washington State.
Ah, okay. So I once came to a soil conference in the States, and are they the almonds? No, sorry. Okay, so organic farming in the States. So when you're looking at the most productive areas in America, in some parts of America, it's the Amish, isn't it? The Amish, they can't use commercial fertilizers and equipment, and they use a lot of mycorrhiza. They use biochar mycorrhiza and a lot of organic supplements. So America was one of the first places to actually commercialize growing of mycorrhizal fungi, so you can buy it there. And you've got mycorrhizal solutions in the States that sell it. I can send you the information. So you can repopulate your garden with mycorrhiza. It does make a big difference. And in Africa, there's lots of areas in game parks. That's why it's so important to preserve areas of biodiversity that still have the natural mycorrhiza in the soil. So you can take some of that soil and put it into your pot plants. And okay, your first question is very difficult, but how long will it take to put 1% of the carbon back into the soil? It would be the carbon that comes out of the air so that we can reverse the climate change. And it takes a long time to put 1% carbon back in the soil, for sure it does. But at the moment we are losing carbon still. So the average carbon in the soil is still going down annually. Ideally, what we want to do is stop the loss of the carbon in the soil and then try and reverse it. But it has the biggest potential to reverse climate change is building that soil carbon up. And also, you're looking at above ground, building the biomasses up. But below ground, you can store a lot more carbon than you can above ground. And when we look at the fires that are happening in Mount Kenya, for example, in Aberdeen at the moment, and this is a big hazard, is if you've got big biomass above ground and you've got very dry, windy weather like we have at the moment, is that biomass can potentially get burnt off. Whereas if we're storing the carbon under the ground, it's got a lot more resilience in it. Yeah.
Thank you.
Thanks, Tom.
Right. Thank you, Ruth, for that answer. Next, I'm going to turn to a question of Sandra Hardy in the chat. What impact do artificial fertilizers have on our soil? Distressed to see the degradation of our soils in South Africa. Are there specific plants or trees that are particularly beneficial to soil quality?
Hi, Sandra. I don't know if you're there. So artificial fertilizers are important because we can't get enough nutrients to produce the amount of food. There we go. Hi, Sandra. So yeah, it's important. We do need artificial fertilizers in order to feed all the people in the world. That's for sure. Putting on too much artificial fertilizer can be very degrading for the soil. So if you put on extra nitrogen, for example, and nitrogen is our biggest crop yield driver. If you put too much nitrogen into the soil, it basically combines with the carbon and it burns the carbon away. So one of the biggest reasons for soil degradation or over application of nitrogen. Also, if you put too many fertilizers in the soil, they can be washed away, they can get leached into the groundwater, or they can run off into the dams, reservoirs, lakes, surface water, and they cause eutrophication. So if you look, for example, at Botswana, at all the elephants that died, for example, from the cyanobacteria, it's not necessarily from artificial fertilizers because there aren't any there, but that is what can happen is you can eutrophy and poison your water sources with too much fertilizer. The good news is in Kenya is that a lot of the farmers they test their soils and they only put the bare minimum of fertilizer required specific to that soil type that's been tested, so they're not over applying. And what we see at the moment is a huge increase in fertilizer prices, which also means that there's a lot of farmers that are going to be using less fertilizers in the future, which is quite good news for the carbon credits, but not good news for the farmers. Oh, and then trees. I'm not very good with trees. I know you get all sorts of different trees that have all sorts of different purposes. You've got leguminous trees, for example. We're blessed with the acacia in Naivasha, and I love the acacia. It's leguminous. It fixes its own nitrogen from the soil, and it builds the soils below it. So I do like leguminous trees. But I think more and more it should be indigenous trees as much as possible, indigenous to that area, and a big mix of trees that help each other.
All right. Thanks, Ruth. Khomotso Morake, could you please unmute and ask your question?
Good evening, everyone. Ruth, thank you so much for your talk. It was very, very interesting. I have two questions for you, but I'll ask the first one and then wait for your answer and ask the second one. So my first question is, what do you think of the use of biochar as a fertilizer?
Okay. I think biochar is great. I think it's absolutely brilliant. It has a lot of potential for improving the soil health and for fixing carbon in the soil. It's got a great capacity to hold water and nutrients. And when you look at, for example, the microorganisms in the soil and the mycorrhiza in the soil, and if you look at a biochar under a microscope, it has a whole lot of pores that can hold and hold the microorganisms inside the biochar to protect them in dry weather, so that when the rains come again, the microorganisms can proliferate again. So I do love biochar. It does have to be be made sustainably, and also it's really good if you can load it. So if you put biochar into the soil without loading it with nutrients, what it does is it sucks all the nutrients out of the soil immediately into the biochar and away from the plant roots. But if, for example, you were to mix it in your compost or with animal manure or with biogas slurry and load it up with organisms before you put it in the soil, you get a lot more benefit from it. But I love biochar.
Okay, thank you. I didn't know that it actually did that if you didn't load it, that it would take all of the nutrients out of the soil. That's very good to know. Thank you. My second question, pardon?
Yeah. No, so if you put a lot of biochar in the soil, you might see what we call a yellow flush, is that your plants go a little bit yellow for a while until everything settles out in. So it's quite good to preload it before you put it in the soil. Yeah.
Okay, thank you. So my second question is, I think, a little bit more philosophical, but there's a school of thought going on that because Africa produces something ridiculously low as 3.6% of the world emissions, then we as Africans shouldn't really be prioritizing carbon sequestration. I don't know how Africa or the African continent sequestering more carbon affects the world or the global carbon emissions, but what are your thoughts on that idea?
Well, okay, my thought is we're all in it together. We're all on this planet. So if the neighboring countries are producing lots of emissions, sadly, it is going to affect us. It's affecting the air that we breathe and the temperatures big time. So the temperatures, and it's affecting our weather cycles. So if you look at the Texas Dust Bowl, for example, when they took out all the trees and the vegetation, they got what we call a regional. They had a regional change in weather that affected them deeply. But now we're looking at a climate change. We're looking at a planetary change of the climate. It's global. So sadly, we're going to have to fix as much as we can. With any luck, the first world countries that are producing so many emissions will be paying the third world countries like Africa that aren't producing a lot of emissions but have the capacity to fix carbon. Hopefully they'll be paying us for what we call environmental services, so carbon capture.
Okay, thank you very much.
Moto, thank you very much. That was excellent questions. Chris, sorry, you were going to say something.
I just said thanks to Motsu. I also thought it was brilliant questions. And I see that Andrew Mati's hand is up, please, Mariti, from Gabon. From the Gambia.
Oh, wow.
Yes, thank you very much, Chris, and to Ruth, very much intense and insightful, appreciative really. Now, in this part of the world, Gambia, there is talk going around, making rounds around what they call climate agriculture crops. Because of the, maybe because of the climate change that affects the rain, doing well to the soil, they want to go that route of climate agriculture crops. Now, to prevent the highly productive, resistant to heat and drought. Now, do you think that's the viable and the good way of going about with nourishing our soil, and so forth?
Hi, Andrew. Welcome from the Gambia.
Thanks.
It's brilliant to have fellow Africans from further up than South Africa on the thing. So I don't know what crops they're planting, but for sure, with the climate smart agriculture, we're looking at crop rotations. So this is better for the soil, definitely. Crop rotations, because different crops take different nutrients out of the soil and they produce different amounts of biomass and put different things back. So crop rotations are really important. A lot of cover cropping and then agroforestry. So I don't know what you grow in the Gambia. Are you growing any sort of tree crops?
Actually, it's mostly rice that they grow here. And as you know, it needs a lot of water. The soil needs a lot of water. And because of, as I say, climate change, there is very limited and it's scanty. The rain is very scanty. That's why I think they are opting to go the route of climate agriculture crops.
Okay. I mean, I'd have to look into it for sure. I know rice crops, for some reason, they're quite good at fixing carbon and for cooling because of all the water that's involved and the flooding and for cooling the soil. But I would have to look into it, Andrew, and get back to you. And we do actually, in Kenya, we do quite a lot of soil testing from the Gambia. You'd be happy to know.
Okay. Thanks, Ruth.
Yeah. Thank you.
Thank you, Andrew. Thanks for the question. I just want to return to a question from Eddie Ferry in the chat. Is it possible for mycorrhizal fungi to be provided to soil through a natural process?
Hi, Eddie. Yeah, so the mycorrhizal fungi, it basically comes in, so you've got spores, which are sort of the dry, eggy bits of the fungus. So those are the ones that hibernate. And then you have the hyphae. So if you take live hyphae from one soil system to another, you can add it back into the soil in the pot plants for sure. Or you, like the Americans and a few other countries do, is that they produce the spore form of the mycorrhizal fungi, and these are tiny, tiny spores, and you need a very, very small amount, and you can mix them with water and stimulants and pour them into the soil so they can penetrate and hopefully colonize the roots. I don't know if that answers your question.
Eddie, you are welcome to unmute and...
Thank you, Ruth. It does. Thanks a lot.
Thank you, Eddie.
Thanks, Eddie. Returning to a question from Prof. William Bond. How do termites influence soils compared to earthworms?
Oh, I'm quite scared to answer that question from Professor William Bond.
And
If I
ask
can
him
come
at
stay
all,
with you
Ruth.
in
Can't
Cape
you cut
Town,
him out?
No. So earthworms take the organic matter down to the soil. That's one thing. Termites also, they move around a lot of organic matter. So they digest trees and all sorts of things. So in that respect, they contribute quite a lot of organic matter to the soil. But earthworms actually, sorry, termites actually move soil around quite dramatically. So when we look at earthworm, the mounds, termite mounds, is we can see that they're moving clay up from the base levels. They move a whole lot of minerals from below, from very deep down, and bring them up to the soil surface, so that they can build their termite mounds. So they're moving a lot more soil around, and they're leaving much bigger channels in the soil than the earthworms. And but they also move and digest a huge amount of organic matter. I haven't looked at the organic matter from the termites. I've more looked at what they do to the soil structure.
So Ruth, just a follow-up question on that. In a healthy ecosystem, termites would be an essential part of the ecosystem.
That's very difficult. I mean, they are an essential part of the ecosystem, but they can get out of control and take away all the biomass, but they're taking it underground. So it's something we'd have to look more into for sure.
I haven't seen Prof. Liesel van Us in the room tonight, but she's always you know, coming up for the small animals and the micro life. So that question was on behalf of Prof. Liesel van Us, if she's not here. Who do we have next? I saw there's another question in the chat from Sander Hardy. What impact has there been on the soda lakes of the Rift Valley?
So, for example, Nakuru's come up quite dramatically. Elementites come up quite a lot. So we see that, and this is about as much as I know, is that the flamingos are no longer breeding there, and Bregoria as well, where there used to be a lot of flamingos, and the flamingos have moved, and I think they're mainly based at, I think it's I can never pronounce it, Longipi. So the flamingos have moved because the higher water levels have basically reduced the salinity of some of the lakes. The other lakes I don't know so much. So Magadi and Natron, I'm sorry, I don't know much about at the moment.
Thank you very much. From Tessa Chamberlain, a question in the chat. Oh, that was just a comment. Ruth, I love your presentation, so incredibly interesting.
Thank you.
Thanks, Tessa.
Marty, I was waiting for you to raise your hand. Please go ahead and ask your question.
We're very disappointed that he doesn't have some soil as the background tonight. It's too dark to take a photo, Marty. Marty, you've got to unmute.
Yeah, no, it only came up now of being offered to unmute, so I was waiting for that. Thanks. Yeah, thanks, Ruth, for the chat. I was just interested, I mean, you referred quite a bit to Kenya and specifically Masai Mara. My understanding is that it is almost a completely man-made environment to a large degree manipulated by humans to be a grassland, and it wasn't previously. So I might be completely off with that, but is there some truth in that? And the mixed use of having cattle as well as wildlife and all of that, having that extra species diversity, in your opinion, does that actually make it better than if it's purely wildlife?
Marty, difficult questions. So from Kenya, I've been going to the Masai Mara since I was a young child, and I don't think it's man-made as it's not due to land clearing or planting. It's a natural ecosystem, the actual Mara Triangle in the Masai Mara. It could be that because of the increase in the animal population or the elephant population, that there's less trees there. Outside the Masai Mara, for sure, there's areas that were cleared in the past to grow crops, and those are being, some of them are being rehabilitated, I guess, for conservancies, and some are still actually being used as crops. But the actual Mara Triangle and everything is a natural habitat that may have changed a little bit due to pressure over the years. What was the second question?
In terms of mixed use of domestic cattle and crops as well as wildlife, almost a mixed type scenario, does that actually improve things compared to if it is just purely wildlife? I mean, I know there are other reasons to try and have mixed in terms of community, etc. I'm just interested from a purely soil point of view, something that's just left for wildlife alone, or if there's a sort of mixed use with domesticated as well as some crop and whatever. That's sort of whole model which is being quite popularized of late.
Okay. I mean, it does it from the soil point of view. It really doesn't matter which ruminants, so a cow or a buffalo. The most important thing is that the stocking and the grazing is controlled, so you don't have too much overgrazing. A lot of work's been done on this mob grazing, for example, which is a bit like the migration of the wildebeest and everything. How it's much quicker at regenerating. But apart from that, mixing the wildlife and cows, I mean, I know you get problems with or the livestock agents get problems with transfer of diseases and pathogens between the wildlife and the cows, which could be negative, but that's as far as I would say. I don't know if I'd advocate it or not advocate it. I don't know much enough about it, but I don't think it would be an improvement.
Okay, cool. And yeah, thanks very much for the information you shared on the, I think it was the rhizomes and that sort of thing. It was, I mean, very, very interesting, I must say. Thanks.
Thank you, Marty.
Tom and Holly, I see your hands. I just want to quickly return to a question in the chat. Ruth, you're going to be very happy about this one. Selahelo Serepa is a nature conservation student, and she is fascinated by your talk and wants to know, how does she end up in soil sciences?
Well, that's wonderful to know. A follower. If you put your email there, I can send you information. I did my training at UCT, but I was in the engineering department. But there's some wonderful universities. I've just done a course with Cornell University on advanced soil health last year, an online course. So there's some really good courses going.
Fantastic. Creating disciples tonight.
Me too.
Tom, please go ahead and ask your question.
Okay, thank you. And yes, I'm a disciple as well, Ruth. Ruth, I'm going to provide you a shameless opportunity for a corporate plug here on crop nuts. My NGO is involved in developing a food sustainability program at a primary school about 22 kilometers south of Narok, Esupatai Primary School. And one of the projects involves designing and building a climate resilient shamba to the scale large enough to feed the school population of about 450 kids. So I'm wondering if crop nuts would be interested in, does your company get involved in that sort of planning at that level? Or what other services could be provided by your company, if any?
Oh, thank you very much, Tom. Now, what we would offer, we can test the soil, for example, to make sure that it's fully balanced and what's required to balance it. So at least when they grow the food, you can maximize on the yield, and also what we call the nutrient density of the food coming off. And we can also help design it. That's not our main, what do you call it? main bent in life, but we have a lot of agronomists at our service, and we can help design a sustainable system. You get some really good, have you got somebody in? You get really good permaculturalists around that can help design a permaculture system that they can all get involved in or not.
Sorry, I muted myself and couldn't get back. I'm not sure. We're in the due diligence phase now. We're kicking off the program on April 25th. And so these are like phase 2 questions I'm getting into here. So that I would have to get back to you on. But I'm really also very interested in your ag tech solutions in terms of micro irrigation techniques and solar powered, solutions and that kind of thing.
Excellent, Tom. Yeah, I can get your email.
Sure, I'll put it in the chat.
We'll link you up.
Thank you.
Tom,
Okay.
Tom, I just wanted to say, I think you and Ruth should connect.
For sure.
That's what we also like to see is the outcome of these talks doesn't just stay in the form of a talk, but practical implication. Lovely.
100%. Thank you.
Thank you.
All right.
Ron, I see we are already 9:15. Let's see if there are any other urgent questions.
Chris, Holly stayed up to now. You have to allow her a question.
No. Holly can just run over to Ruth and go and chat to her herself. Come on, Holly.
You don't want to go over to Ruth at this time of the night. There are hippos.
Yeah, and also I'm now house sitting a good 2 hours away from Ruth.
Okay, then we'll allow you, Holly.
So I have one question and one kind of statement hearsay. So I did all my undergraduate degree in Australia, and we did do quite a bit on soils because a lot of the universities, the geology departments are controlled by the mining departments. So the mining departments write the curricula for the geology departments in Australia, which is quite interesting. I think it's changing a bit. But of course, there was a lot put down on hoofed animals in Australia because they're not native. So cows compacting the soils. So, when we talk about, and Marty's question, what about having cows or having buffalo, for example? Well, I mean, what do we really know about soil compaction? And is it really something that the Australians should be getting their knickers in a knot in about?
Holly, yeah, you can get a lot of soil compaction from hoofed animals and any other animals, actually. If you get a point source with a weight on it, if you have too many animals walking on the same area, you get lots of compaction. If you look to that NDVI that I put up with the different colors, you can see where the animals walk. So generally they tend to walk on one path. But when you're looking at cows moving through the bush, you can see that they actually sort of spread out a lot more and create a lot more areas of compaction. So livestock do cause compaction, but if the soil has enough organic matter and you've got the soil aggregates in the soil, then they resist being compacted. However, if the soil structure is completely gone, then the soil compacts really easily. And maybe Australia's got very fragile soil.
Yeah, I do recall somehow learning that. Now, my second was a totally different thing, but we talked about moving soils. Now, I don't know how true this is, and Ruth, you will have heard on the Ruma vine in Kenya, but the Chinese put in the great big railway, and apparently for every container load of bits that they brought in to build the railway, they took soil out. All of those containers went home to China with soil. Now, let's suppose that it's true. What are the sort of implications of now all of that Kenyan soil in China with all of the fungus and organisms and things that are not used to being there?
Yeah, it could cause problems. You're absolutely right. I mean, I know from the agricultural point of view, from the agricultural side, is that if you're exporting product, which to some countries, like Australia is very strict, Japan's quite strict, China's quite strict, is that it has to be fumigated before it can go into the country. So it's quite possible that they're probably treating the soil before it goes in.
Okay, thank you very much. That's me over.
Thanks, Holly.
Thanks, Holly. I think politically you should put a land claim in China. I
Roland
think
Goods.
Roland
Yeah.
asking a
Roland
question.
Goods.
Thank you.
Yeah, thanks, Ruth. A couple of talks ago, we discussed dung beetles, and the issue related to medication for cattle. They discussed in Australia things like hydroxychloroquine, and how about, well, a very large percentage of that medication passes through the digestive system of the cattle. And I'm just wondering, in Kenya, in the Mara, if you've experienced any problems with die-offs or things like dung beetles because of the poisoning in the soil by the cattle's medication.
Hi, Roland. Thank you. That's a good question. I don't know too much about the populations of dung beetles in the Mara that have been affected, because I haven't looked into that. I do know that actually medication and pesticides, so this synthetic medications and pesticides that can't be broken down naturally do become a problem in a lot of habitats and populations. So whether it's tick dips or weed killers or insecticides are big as well. They're the synthetic ones, some of them don't break down, but I see more and more there's a movement towards lower toxicity chemicals, and ones that have a much shorter half-life so they don't persist in our system. So there's a lot of awareness going on about that and a lot of development going there. But I'm sorry, I can't answer you about the dung beetles.
Okay, no, it was more about the hydroxychloroquine and the medication of cattle with that parasite to remove parasites in cattle. And I think that it probably affects a lot more than just the dung beetles, because it kills. That's why they administer it for cattle, for the parasites in the cattle. And I'm sure that it's not just the dung beetles, but hydroxychloroquine, because it passes through the digestive system, goes into the soil and stays there, and could be, I don't know, I'm just asking, a problem for the soil biome, for the soil, for the system within the soil and everything that lives in it.
Yeah, I think you're probably right. So some of these parasite things, like they kill the worms in the stomach, the helminths, and they kill the worms in the soil, and they can build up in the soil. So they can be a big problem. And using herbicides as well, for example, which are designed to stop plants growing, they have a massive knock-on effect with the fungus and the bacteria in the soil and the protozoa and the algae. So these chemicals that are used to treat one thing can end up being a problem in a different area, for sure. And I think Tom sent you a note, a chat, put something on the chat about it for you.
Thank you.
There's a chat there. Yeah.
Okay.
Thanks, Roland. Just returning to the chat, question from Kagisu. Can mycorrhiza be of any impact on desert plants?
Yes, for sure.
Fungi.
For sure, you get different mycorrhiza for different areas. So there's all sorts of species, and you get ones that are used to sort of more moist and cooler situations, and then you get ones for the hotter situations. And if you looked at my picture of the candelabra and a lot of the euphorbias and the cactuses, they do work. They're very beneficial. They work hand in hand with the mycorrhiza, but just different varieties of mycorrhiza.
Okay, Ruth, another question from the chat from Emmanuel, and I'm assuming he's referring to a model, and I'm assuming he is referring to it in the sense of a climate model that predicts future possible outcomes. I want to know if there is any soil and resilience. If yes, how reliable is this model?
Sorry, Johan, I missed the first bit.
Okay. He wants to know if there's any model for this healthy soil and resilience. If yes, how reliable is this model?
There's a lot of different modeling types for different systems, basically. And they, so you model them and then you trial them and you just keep developing them. So it's ongoing.
Okay, so that does exist. And if he would like more information, we will put him in contact with you, Ruth.
Thank you, Johan.
Thank you very much. Am I missing any questions at the moment? Maret, is that all from the chat?
Looks like it, Johan. I also think that we're coming to the end of our time here in terms of recording anyway. Just one or two comments. If there's a last question, you can just raise your hand or put it in the chat. Also just going through the list of people here tonight. I see Colin Bell. Hey, Colin Bell, another guy who must give us a talk again. I will follow up with you. Ryder Mail, good to see you. Good to see you, Anne Mounted. Johan, let's check. Any other questions? Doesn't look like it. Cheryl Ogilvie, thanks to the TUT students. I'm certain they've learned a lot tonight. All of us have. So to the TUT students, also you joining us tonight, I'm sure that this was a learning curve of note. Thanks for that. Also to the team behind the scene, Johan and Ruan and Maret and Duret and whoever's in tonight. I think they're the team behind the scene. Really appreciate that. Also want to remind about the giraffe talk next week. Fred, what is it? Beckerweit, is that the name?
Berkowitz.
Yeah. Berkowitz. Oh yeah, I couldn't read my own handwriting here. Fred Berkowitz. Also looking forward to that talk, and thanks, Johan, for the very professional way and you are guiding it. And Ollie McGock, time to go to bed now or drink your tea.
Sorry, Chris, can I add? Ruth, thank you very much. My students do soil sciences. It falls under life sciences now. And what you did tonight covered a hell of a lot of their theory. And I think it made sense. I think the students that were online benefited. And I think they definitely will now pass the next test. You made it simple, you made it easy to understand, and your slides were to the point. Thank you.
Thank you very much, Cheryl.
So thanks to all of you. And again, thanks, Ruth. It was really, really special. And I'm extremely impressed with the way that you do things and your knowledge and how relaxed you are doing it. And while you're talking, you even read the chat and answer the questions. Well done. People normally don't do that. Thanks. And Johan, thanks also. Between you and Rowan, you are very professional at this. So thank you very much. Okay, I wish you a good morning, Tom Totteman, and I wish the rest of you a good evening.
ACL.
ACL, there you
Bye,
are.
everyone.
No, you got to come. No, now you got to come in. Sorry. Hello, CL.
Oh, hold on. Hi, can you hear me?
Yeah, we can hear you, CL.
Sorry, we were watching on the big screen TV, so I wasn't able to unmute myself and speak, but I've managed to work it out now. So hello, everyone. Nice to see you all.
Hello, CL. Just for clarity's sake, you were not watching television while your mom was talking. You were watching your mom on the big screen. That's what you did.
We were watching. Exactly. Thanks for the clarification.
Thanks, Pauline. Thanks, everybody.